ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಅಲ್ಲಿ ಪವರ್ ಇಲ್ಲ ಇವತ್ತು ಅದಕ್ಕೆ ನನ್ನ ಮನೇಲಿ
ಸರ್ there is some power issue in Professor BRS house. Kindly, I request all the participants to be kindly be patient. In a minute, we will start this program.
ಓಕೆ ಬರ್ತಾ ಇದೆ ಇದು ಪವರ್ ಪಾಯಿಂಟ್ ಮೋಡ್ಗೆ ಸ್ಲೈಡ್ ಶೋ ಹೋಗಿದೆಪ್ಪ
Raghuveer will introduce the speaker, then we can continue.
Okay.
Raghuveer, over to you, Raghuveer.
Yeah, thank you.
Bye. Hello.
Good evening, everyone.
Yeah.
Professor B.R. Srinivas Murthy graduated in civil engineering from Mysore, and then he obtained his master's degree in soil mechanics from IIT Bombay in 1968. And for a short period, he was an SRF under a CSR scheme at IIT Delhi. Then he served as lecturer in civil engineering at SIT Tumkur during 1969-70. Then he joined PWD as junior engineer and served 2.5 years designing major irrigation project structures. He spent short period of 8 months as assistant design engineer with Mecon in Billai, designing steel plant structures. His passion for teaching brought him back to the academics and joined University Visvesvaraya College of Engineering of Bangalore University as lecturer in 1973, then became reader in 1981. He obtained his PhD from Indian Institute of Science, Bangalore in 1983, for which his thesis awarded with Professor G.A. Leonard's Award of IGS and Professor P.S. Narayana Medal of IISc. In 1984, he joined Indian Institute of Science, Bangalore, and became professor in 1998. He served as a registrar of Indian Institute of Science for 3 years, and he superannuated from Indian Institute of Science in 2005. In over 2 decades of his service as professor at Indian Institute of Science, he guided 14 PhDs and 7 MSc engineering theses, in addition to scored ME dissertations. I am also one of his student of MSc engineering guided by him. He has published over 100 technical papers in international journals and conferences. He has also co-authored a book titled Analysis and Prediction of Soil Behavior with Professor T.S. Nagaraj and Dr. A. Vatsala. His areas of research interest are constitutive modeling of fine-grained soils, including cemented and unsaturated soils, CAM-CLAY models, reinforced earth, reinforced soil beds, and ground improvement techniques like micropiling, grouted anchors. Professor Murthy has very widely traveled abroad as a researcher, fellow, and visiting faculty. Professor Murthy has been conferred with many awards, including the Fellow of Institution of Engineers, Honorary Fellow of Association of Consulting Civil Engineers, Life Fellow of Indian Geotechnical Society. He has been awarded IGS Afghan Kukelman Award in 2004, Distinguished Engineer Award of the Year 2006 by Institution of Engineers India, and Outstanding Civil Engineers Award of ACC in 2008. Professor Murthy has been instrumental in successfully constructing several vehicular and pedestrian underpasses below highways by box jocking technique without disturbing the road traffic. Protection of deep excavations up to 25 meters depth with soil nailing techniques in major cities in India has been his current field of activity over the last decade. Alternative foundations on filled up and weak soils are being handled regularly. Professor Murthy on several committees of state government, either as chairman as a member. He is chairman of technical advisory committees of BBMP, Karnataka Health Services System, Karnataka Police Housing Corporation, and CMTI. He is member of Task Force on Quality Assurance in Public Works, Government of Karnataka, Project Management Group of Indian Institute of Science, Karnataka Power Corporation, and Karnataka Slum Clearance Board. Thank you.
Yeah.
Over to you, Professor.
Thank you for nice words, Mr. Raghuveer Rao, as
Thank
well
you.
my good friends. Okay. Though it is not an occasion to elaborately discuss private things, I only wish that all of you are safe in the COVID period, this bad worse period. Okay. And whatever the presentation that I make today are basically based on people posed the problem from the field. Sitting in a room, you can't think anything positive, or you can go to the Atma, but not to this soil mechanics solution. Therefore, some people instigate you to think. That's where exactly I thank all the people who done that. The first slide what I have put here is called soil diaphragm wall. This I think you can see, Partha.
Yes, sir. Yes, sir.
Okay.
Continue, sir.
Now we
This
can
is a totally new concept which I developed somewhere in 2009 or 8. I don't remember exactly. The LNW, a Singapore-based company, had taken up some deep excavation in the production system up to 14 meters in Outer Ring Road for RMZ Group. And behind this, they did not realize within 4 meters from the face of the retaining, rear face of the retaining wall, Honeywell project is there where they have got a lot of service lines underground and they cannot permit any grouted anchors or the nails to penetrate into that. So they posed a problem, sir, this has become a problem. We want to go for the diaphragm wall, RCC diaphragm wall. And then again, to make it as a cantilever RCC diaphragm wall, how much you have to embed, how much you have to deal, this is a major issue and also cost. Then somehow we had done a lot of work with a single row of micropiles and then anchoring into the neighbor's property or adjoining area. Here, there's no scope for that. Then I decided that, can we make like this? We insert 2 rows of micropiles. One is here and another is here. This is exactly in the rear face of the retaining wall, whereas this is very close to the boundary. And this width available, required is B. If it is shorter, I may require B equal to 0.35 times H. Then it is self-standing with only 2 meters of nominal embedment. If B is not available, then I may have to go deeper for this line. That's what we have done it actually. So the question is, this is the earth pressure coming here. This generates a overturning on this mass, and therefore this self weight of the mass here will generate a counter moment. And again, there is a frictional resistance which can come here, what is shown in the red. This will counter this again, this moment. The total, this plus this, that is called here 2 and 3, this must be greater than this with a factor of safety. That's exactly the concept which we developed. Now I'll give you the details of that. Let me see. Anybody can generate this mechanics wise. There are 2 rows of micropiles, 1 row along this line and another row is along this line. This is my excavation line, virtually rear face of the retaining wall. Again, retaining wall for 14 meters is not 500 thick, 600 thick. It's only 200 or 250 thick because earth pressure will not be there. I'll show you that later. So then you can see. And there is a capping beam here. What is this micropile? Generally, when I open it further, you'll know that. Between these two, I introduce a N girder so that the stability is important and the whole thing acts as a mass. Now I start working on this. We provide an embedment for the concrete on this, like this. About 200 mm thickness of concrete is laid all along this, entirely put there, so that even the construction vehicle can come on this. That's what we did here. You can see now. And then we go incremental excavation, not sudden excavation. Everything is done by incremental excavation. And then we drive the short nails. These short nails, this is a Honeywell property. It will not go beyond our barricade line here. So, which was only about 4 meters or 4.5 meters was the available length. We driven that, you can see now. Once we drive that, we fasten weld mesh and then we put the shotcrete on that and continue the steps. But once I go up to certain depth of 3.5 meters, I may have to provide an additional stability for the micropiles. You can see them here. This we call it a snug fit and welding. This will be cut to the shape available here and then in between them weld it. You can notice one more thing here. The weld mesh shall never be welded to the micropile or to the nails. It shall be fastened. On the top of that, I have got a small strip of MS strip, and then that is welded to the micropile. Or I can have a crossbar. That crossbar is welded to the it is placed outside the weld mesh, and it is welded to the nails or to the micropile. That's how one has to do it. And again, you can see the groove here. This groove has been cut here in the soil, and to embed the what do you call whaler beam or whatever the beam you want to say, it's a lateral separate. It's snug fit and welded. Snug fit means it is cut to the shape here, cut to the shape here, and it is welded from here when I am at that level. I can keep on going like this. Then you can see this one. This is another one. Same project. Next, you can see together. This is next level. So you can see the snug fit and welded whaler beams have been provided here, and this is coming here, maybe going to one more level. That is absolutely required to maintain the stability of the front line of the micropiles. And whereas the rear side is already embedded fully, there's no problem for us. And here again, we have done it in the cross direction. You can see now, this is how it comes here. We have gone up to the full depth here, you can see. This is standing on its own. Why I should design a retaining wall for earth pressure? There was a major difference of opinion with the structural engineers who are supporting the RMZ and the LNW. Then they came back and said, yes, sir, we agree. That is the reason why the thickness of the retaining wall here is not retaining wall, it's a basement wall. It doesn't retain anything because this is standing on its own. And when we cannot drive the bar, this is the point. Driven bars have got a limitation that it can take more time to drive. Then I go for one row of grouted nails or two rows of grouted nails depending on the situation. Here the total depth was 14 meters. We introduced grouted nails here, 2 rows. These grouted nails have one problem is I have got this what is called whaler beam projected out. It will be embedded inside the concrete. That is the reason why we went for another 50 mm extra thickness up to here, and when beyond that, above that, it's only 200 mm thickness. So that is a beautiful work. Now I might have done about, in fact, our Basavaraj from structural engineering group, he said, sir, you have converted the soil into a structural element. It is something different. Yes, I agree with it. Yes, together it's working. Even in Nepal, we are doing, even in Sri Lanka, we did, many places we have done that. I hope that you can. You don't need to work. In fact, one gentleman asked me, sir, have you patented this? Sorry, I will not patent anything because my founder, institute founder has done it, Jamshedji Tata. He has written a will that the outcome, research outcome from this institute shall be in public domain. That is the reason why I have not patented anything, though I had many occasions and many chances to make the patents. I will not be doing that. Thank you very much for that. Next one. This is a very typical situation. It is called a Terra link wall, but they can't call it as, I can call it as a geotape linked wall or anything. This was, I don't know whether some of you are familiar with the Bangalore. This is the outer ring road to the Nayanhalli. This side we have got the Nagarbavi. There is a cross behind this, there is a bridge linking Bangalore University or the Institute of Management to Vikariyurao Institute to the rest of the area this side. There is no service road here. In this side, there is service road, left side. Whereas the right side, there is no service road. They were struggling to provide this right from, this is, you can see the board here, 26/4 to 20, this is the photo, not later. But they came to me, said, in BD, I was also a technical committee member. They asked me, can you do something? Let us think over. One thing I can assure you, civil engineering is the one field which can find a solution for every problem. We should have that attitude to do it. Then what is the space available? Sir, there are a lot of multi-story buildings above here. They started telling. So I went around. Then what we did, you can see here. This is again in 2012, I have signed this. That is 2010 end. This is 2012. After 1.5 years of discussion and everything, it's in the existing ground, I'll put the grouted nails. And for tension here, I provide anything, we may use the steel, but they preferred that it should be precast elements we will use so that it looks elegant or something. They didn't want a blank wall. Therefore, we went for the RE wall panels here. And these RE wall panels are interconnected to these grouted nails here with the TerraLink. TerraLink means it is a polypropylene material which can take enough tension on that. You can see that. So layer by layer, we can do the, this could be taken care by, fortunate things, TerraLink is available with different strengths, right from 4 tons, 6 tons, 8 tons, like that, the tensile capacity of that. So, but we can have capacity here based on that number of layers we can put it here. And in fact, this is not fit, what do you call, a buckle, turnbuckle system, where for the rod here, I have made this turning, and then this link here, you can see more beautifully photos. And this is how drilling. It is not that everywhere I am getting rock. You may get soil like somewhere there. And again, link. You can see the drilling, how difficult it is. You can see the building, how close it is. We have got hardly about 9 meters above to make the road. So then we use the precast slabs here. You can see here, RE panels. These RE panels have been brought here and agreed a small foundation, and then backfilling with a proper material. For this, we prefer risk-free. It shall be self-retraining, everything like that. It's that's why we went for a granular material, maybe from the manufacturer side. Okay, you can see now how compacting. You can see before that itself we have driven here, drilled here. These are all grouted nails. It has been brought here. At this level we do this, and then when I go up to here, then again do it. You can see the nail layer. Then how we link this, you can see here. This is what I said, the bar from inside, it has got a threaded system. I get a turnbuckle here, and I take the Terra tape here, round this, and can you believe that this can come even to 100 meters length, 160 meters length. We go by this and winding here like this. And this is the precast element on the back of that. We have introduced a rebar. This is a bar, galvanized bar, so that it doesn't corrode. And these are the hooks which have been embedded into that, and then it holds it. You can see now. This is the panel. At each level, we have doing that. You can see. Going. Again, layering above. One more view of that. Another view. You can see how bad it is. There you see a hard rock. Here you may see soft rock. You may see something very bad also. And this is how you can see the panel is interconnected with the return wall of the underpass that side. This is the underpass which we are coming from the outer ring road. And next to that we are building it. And above this, I can see the buildings which have come up there. You can see the panels are sitting. You can see now much more. And more additional drilling. I mean, these are all additional photos, how bad the site situation, everywhere. It is about 600 meters length, not 1 or 2 meters. And when we do this, we may find many problems, hard rock here, maybe soft one here, something here. We should be ready for all that. If I find it soft, for example, if the drilling time taken is 3 minutes per meter, I may use one parameter. If it takes 8 minutes per meter, I may use another parameter for the friction. If it takes 20 minutes per meter, then I may use something else. This is what the field engineering is required. And this we successfully did that. You can see top crash barrier. This is the portion. On that side, we get our thing. You can see the road coming that side. Height, you can see 6 elements, 5 elements. That means up to 10 meters height it has gone. You can see one more view. This is a blasting rock, and here it's a stone masonry work that has been done. Their house has got an entry from that side here, and still we have to work without disturbing the road. I mean house. Fortunately, we were successful. And can you see here, we have removed the stone, and then we have introduced into that the grouted nails, anchors, and finally the wall height will come up to here. Okay, you can see that. This is the crash barriers are being constructed in the top, which covers the top of the thing. You can see after that block topping. This is the width of the service road, which is 7.5 plus something. because minimum is 2 lane. And then we have got the footpath here. You can see another view of that. Some places we have been left above, let it be there, but we have not touched it. We have taken what is the required width for us for the road. That's all the point what we say. You can see one more view. You can see the full length from here to there. It is 600 meters, 0.6 kilometers. More clearly visible. And this is the inauguration day. So why I said is, generally, theoretically, we can't sit in the laboratory, I mean, classroom and think about what should be the solution elsewhere. Unless the field people pose the problem to us, nothing can come. Honestly, I have learned everything only from the field people, not from anything from the textbooks, honestly. What I studied is the engineering is different, master's degree is different, and what I did something. But subsequently, everything in life that I have learned only from the field engineers and solved their problem. That's the point. This is a very important work. You should see that. Tata Housing has got a major 3 towers in the southern part of the Bangalore. That's Banchankari, Vermont site. There was a major issue. This is the lowest level of the site. And I had to construct a road here of 7 meters width, 7.5 meters width, and height varies from about 3 meters to 8 meters. And then this road is to go to the hilltop. You can see this side goes up above like this. The towers are on the much higher level here. So this is the existing ground, and this is the required pavement, and this is the wall that we are constructing. There were choices whether we can go for the precast elements as we have done in the outer ring road, or should we cast a, oh, they said, no, sir, we will cast it here, sir. Okay, then I said, can you believe that this is only about 300 by 300 foundation? And this is only 150 thick RCC wall. You can see better later. And we are drilling through this system. This is the top of the hillock is something like more than 300 feet, 400 feet above this level. And we go gradually sloping up. This is the grouted nails drilled and anchored here. Bars have been grouted here. I don't know, many of you may not be aware what is that grout. Generally, it's a pure cement slurry with non-shrink grout compound. Water cement ratio is 0.45. With that, we should grout it under a pressure of 1 to 1.5 bar, not less than that. It shall be always by tremie type from bottom up, we should grout it, not from simply pouring. Some people were doing only with the gradual gravity flow type. No, it's not right. Can you see here? On the surface, we have installed the grouted nails. The time taken for each one to drill, based on that only I design, because I don't know how the pull-out capacity varies from point to point. So based on that, how much time it has taken, based on that, we have recorded it. And then you can see the cement slurry, which has flown after completely grouting up to the top level. It can come here, it flows here. It's a method. You can see the rock cutting here. All such things are available at site. It's not a simply pure isometric, I mean, isotropic homogeneous material for us. We have to deal with the natural soil as it is. Now we can see, this is about 300 by 300 foundation. This is, and then you can see the 150 mm wall thickness, but this is the reinforcement, again nominal. I don't prefer anything, but it can be designed for the tension, whatever that is available, etc. And here, this side, we are not going, we are going road up to this level height. I think this goes up to that. And here, gradually going up here. Here, the height is less. As I go up, it goes on increasing up to here. And then takes a turn here. We have done something different there marvelously. Let's see. Then you can see that this is the excavation being done somewhere there, or the drilling. Then you can see the reinforcement, I mean, driven grouted nails here. Can you see the bars here? These bars are to be connected to this. So first we put this and then put the concrete, and then the wall is ready. Then we embed a plate here. This plate has been connected to this by welding. This is the first project that we did like this. Therefore, we welded it like this. And subsequently, I'll show you the improvement what we have done. You can see that. Depending on the capacity, it is linked to one place or 2 places or 3 places. If the strength of the grouted nail is very large, quite high, say it is 40 tons, then I may require only 30 tons or 20 tons here. Remaining 10 tons has been shared to this. This is how we have redistributed the entire thing based on the data that we had. The data is based on the time taken for drilling, time taken for getting the up to the bottom level, what is the length of that? Based on that, I calculate the frictional resistance. Based on the friction, simplest calculation of frictional resistance is 1 N equal to 0.1 ton per square meter. So based on that, if the N is 40, 50, 60, based on that, I get it. Or if it is rock, I have got a methodology for that. In fact, your literature is wonderfully focused on that. We can go for that and we can do that. So connectors between the anchors and retaining wall. You can see some more. People asked me in the beginning, why did you scatter so much? Because this has got a one strength of the anchor, where the next one may be something else, following next something else. But I may require uniformly distributed pressure on this, and then I have to counter it. Therefore, I am giving a number of things here. From here, maybe 4. From here, maybe 3. Somewhere here, maybe only 2. Like that. That depends on strength that I have got in the grouted nail. This is a very different concept which you did. And I can see that from that side. This is the road level. Ultimately, we go up to there. This is the road level on the, it is also sloping ground. I have to reach the top level. So this road is going up like this and turns here. So we have to build this wall up to this height. You can see now. Can you see the height? This is the thickness, 150 mm. And you can see the reinforcement, everything. And structural design has been done by our Chetana consultant. They helped us in concrete optimization. There's no doubt in that, Mr. Swaraj. And this is the turning point. After this, what we did, I'll show you. This wall stops here, but after this, we didn't do the wall. Another point is, sometime later, I'll show you. The neighbor has built a tower here. Later, after this, very close to this. If you had not done that, it would have been a tough job. You can see parapet has come here, and weep holes have been given. Everything. No compromises have been made there. And actually, before this, I had done this also. I mean, one place. This is called anchor wall for a resort in Kodaikanal. What is that anchor wall? Why they required? They didn't have the parking place for such a huge resort where more than 100 cars will come and park. So they approached me. Then I got a good friend in Chennai, and I told him this can be done like this. Immediately he said, sir, I'll try everything, sir. Can you see here? Instead of plate and welding, we have fixed here ISMC. And on the bar also here from the grouted nail, instead of turn burner or other things, I have put a channel ISMC piece that has been welded here and has been welded here. This is how the things can be done and improved. Here you can see now. And backfilling, they had a lot of material, excavated material itself, rocky material. You can see it has been dumped. And this is our, to make the drainage system here behind this, we stacked the fellow here like this. You can see the aggregate of the rock mass has been stacked, and behind that I put the grouted, filter material. And this has been compacted by properly. You can see one more view of that. You can see the height. It goes up. Can you see the marble? This is almost a kilometer length. You can see the building on the other side. There is a building already. Below that I'm doing without endangering any of these things. This is what I said. This is the channel that I embedded onto the, welded to the rear side of the retaining wall. And then the grouted nail bar comes and welds against this. I don't need to bend it. I don't need to, for example, in this case, I was bending here, but now I don't need to bend it. It has been welded here without cutting. Because bending is always a dangerous thing for a tar steel bar, and it goes out after welding particularly. So that is how we have done in the Kodaikanal, and it's more than now 15 years, absolutely performing normally. The resort from here, people are parking the car from there to here. Next. This is a very interesting study. This is in Lavasa city, which is Asiana Group has done it very close to, from about 100 kilometers from the Pune, on the hilltop only. And there was a major issue that there is a collapse of slopes from the rear side. They had cut it something badly somewhere, and it came down up to the, so you can see it has failed here. And they had not done a proper protection system there. And this side I have got the flats here. This has come up to the flat, I mean, apartments or units, housing units, resort or the units. So then what we did is we went for a gabion wall, available rock. This is the gabions which have been placed here. The one method what we adopted is, it's a gravity system, no anchoring. We put on the soil on the rear side geotextile filter cloth, which can serve as a filter material there, so that the soil will not migrate from the slope, will not migrate into the gabion. And below that also we have provided a this material, filter layer, geotextile filter cloth down below also. Then you can see now, this is how it goes along this soil surface. This has, it is actually a forest type. It had fallen up to here fully and trimmed it, and then we started putting the geotextile filter cloth on the surface. And then you can see the gabion is this. The gap between the gabion and the geotextile filter cloth, which is available so much, we filled up with aggregates. We filled up with rock fill. Then the next layer of gabion will come and sit on this. It goes up again thickness. As I progress up, the rear side thicknesses also reduces on the slope of the existing system. This is how it should go up. You can see here some more view of that. And we used the available rock fill in the local area, not anything like what we wanted to. You can see here. These are the housing units, ground, first, second. And there was a major issue of this entire thing collapsing here. It had blocked the ground floor completely. And the entire thing, we started working on that. We have given the gabion protection, and then it goes up to here, up to the top here. 2 floor heights, you can see. And in some places where I get more space, I give the offsets in the front, and the rear side I fill up with the rock fill only, so that I will not just waste my material. So it's only one layer of about 1.5 meters or 2 meters thickness here. Height is 1 meter, length could be about 3 meters. So this filled on the rear side, filled with the aggregate and then continue. This is the line where it goes. You can see one more view of that. Almost 8 meters, 9 meters, some places 6 meters, like that it has come. And it's more than 10 years now, it's standing on its own and fine. Things are happy. And one beauty is, from there, whatever the rain water enters, it goes through this, because it's filtered and comes here, and we have made a what you call French drain below this level at the edge. That automatically flows out, and then there's no problem at all. Nothing choking taking place so far. This is a very interesting project. Here in Bangalore, near what I call Dayanand Sagar College, after that you go straight from there to the westwards. There is one ISKCON project, which is on the hilltop, is different. This is a prayer hall, and there is a kitchen. The entire land behind this is BBMP land, but collapsed because of the rain, and they had a major issue at that time without sacrificing the thing we wanted to do. So we did this. You can see here. This is the above, and below that, this is the BBMP. Whole land is that, and in between, from here to here, BBMP land. But they did not permit us to use anything, because they said, no, we may have to, we can't use this, you have to. Can you see the geotextile filter cloth on the rear side? Same principle as I said there. From here, we spread the geotextile filter cloth and then go on that, and the gabion is put here. Can you see these lines? These have been put only to preserve the straight line, everything, so that if something is projecting, we should kind of, and we have followed every principle of gabion, where the vertical joints are to be broken. There are some places where we can't do that. I'll show you later. See, these are all how we have done it in a very systematic way. And it's also gravity. In some places, we have gone for some grouted anchors, but BBMP said, no. Therefore, we have managed to get the rock fill from there to here, which is capable of withstanding on its own. So this is how it was done. This is very, perhaps the last part of the discussion, I can say that. Can you see, this is the hilltop where we went down through the road we formed, and we stopped the what you call RCC wall there in the Tata housing. But further going up is a difficult task. There's nothing like collapsing here. So we need to protect our own slope because here 20-story, 18-story buildings are coming up on the top. So then we decided, and there was also one issue was there. NGT, National Green Tribunal, had given by that time, the material that you have excavated here should be reused. You have to consume all the material that you remove from your site. You can't dump it elsewhere. Can you believe that similar situation happened for the same Tatas in one of the projects in Nagpur? They had set up such a dewatering system, and they were flooding the what do you call stormwater drains or even the sewage lines inside the city, and it broke open. Then everybody virtually started shouting. Then they came back and said, you had to consume all the things. That is the important thing. Here, what we did, almost 3,000 cubic meters of rock had been excavated. What do we do with the rock? Then I told them, let us use it as a gabion, and then the protection system itself can come. But instead of making gravity by itself, because this height is almost 14 meters, like that it goes, I'll show you. Then we went for anchor. This anchor, how do we connect here? Into the gabion, sorry. Yeah, into the gabion, you can see that I have installed here the grouted nails here, and then it's installed the gabion here, and then fill up the back portion with the rock fill, and then second one will come here. This grouted nail will go inside. I weld a channel section to that here so that I can fill up later. These are all filled in position. It is not from outside. Majority of the time we bring the gabion filled readily and then place it. Here it is not possible. We have to fill up here. Where this side you can do anything, I don't mind. And this has got a small slope so that it reverses, it balances with this. You can see that. And here it goes up like this. Perhaps if you see the photos, you'll see better. Here one problem was there. I told you that these joints are to be broken, horizontal and vertical. But vertical joint has not been broken here. But fortunate thing is these are all anchored. If it is a gravity by itself, it can stand, then I have to break this. That's what we did in the other case. You can see that. So this is very crucial design detailing. You can see each one is almost 1.2 meters height and goes up like this. You can see some places it's almost 14 meters height. It's 8 to 10 meters is average. And the gabion has been used completely. We consumed all the 300 cubic meters of 3,000 cubic meters of rock that was removed from there to there. Can you see the tower here? These are the towers. And here you can see the level, basement level is, roof level is here. And somewhere here it will be height, it will be more because this is sloping down. This is a hill ridge on the 3 directions sloping down. So this is what we could achieve there. You can see construction detailing. But one thing is I was not happy with the McAfee did not do that job properly. They should have broken this also. But fortunate thing was it is anchored one, therefore I'm happy and safe. And so far no damage has taken place for last 8 to 10 years. See, this is a circular building. You can see one more of the same Tatas. Okay, that's it, fine. Yeah, that's what I was referring. This is our RCC wall that we have built from there to here. This is a circle turning. It goes further where this is the tower, down below, behind our, in front of our RCC wall, they are building the towers after towers. This entire area will not be as we saw in the beginning. Now it has come up very well and it's going up well. You can see one more. We have that. So thank you very much for things. Sorry, I finished a little early. Thank you for your any questions if you have, or if you have time, I can project something else also. Parsarthi.
You can take another 5 minutes and no problem if you have something else.
That is only for discussion of something else. I can say that. Not by the time, let them have some questions.
Yeah, I think there are few questions are there.
Yeah,
you can unshare the screen, sir, for a minute.
Unshare. How to do it? How to do it? Tell me.
ಮೇಲ್ಗಡೆ ಅಲ್ಲೆಲ್ಲ ಬರುತ್ತೆ sir on the red stop sharing ಅಂತ. You can stop share the screen.
Yeah, stop sharing.
Yes, sir. Stop sharing.
Yeah.
Yes. So for all the participants, I have put a Google link form. Kindly fill up the Google link forms. We will circulate and share the copy of the PPT. There are any questions are there, please post in the webinar. And there are few questions. Bindu Madhava has a question. Bindu Madhava, can you ask the question, sir, to Professor? You can unmute and speak.
He is not unmuted. He is still there.
Okay. He says the case study 3. What is the backfill material? Is it granular material? And how the backfill was compacted for case study 3? That was
What is that case 3? You should tell me. Is it?
The one where you welded, no, that bars are welded.
Oh, no.
The
That is
very
simple.
close.
No, nothing.
Yeah.
You can bring any material and dump it. Actually, it is a highly granular material of the hillock, and we excavated and dumped it there. And the plate vibrator layer by layer has been done there. You can't have any roller system there. No heavy rollers. It is a only simple plate vibrator rolled and compacted. And also another thing you should know that in an anchored system, we don't depend on the friction. Please note it. We depend on the tension. Friction comes in the anchored portion. Anchored portion is grouter anchor. So the strength capacity of the bar is already taken from that. Therefore, the here is only backfilling and holding it. And even nowadays, I'm suggesting for one group in KRDCL for an RE wall, instead of building RE wall, I build 2 walls of 200 mm thick and tie in between them with a rope. What is that rope? Garware, a wall rope, are producing the ropes in Pune with the polypropylene, polyethylene, polynylon. Capacity must be surprised. Breaking strength will be minimum 10 to 12 tons, goes up to 120 tons. Even if you use 5 factor safety, I can design it for 25 tons. That is the capacity. Therefore, I can tie the walls here and then fill up with any material. Nothing will happen. Friction you will never lose. No, I'm not worried about the friction at all. It's only tension.
Yeah. There's one more question. Sridhar has a question. Sridhar, can you unmute and speak and ask your question, please? Sridhar. Go ahead, Sridhar.
Hello.
Please go ahead, sir. Please go ahead, sir. Ask your question.
Sir, actually that MS bars and steel channels are drilled and filled in the soil you are showing. In the future of the time, the corrosion will not happen, sir. How you will control that one?
Actually, one thing you should realize, 2 points. If it is a frictional one, yes, with corrosion, friction increases actually. Yeah. Whereas the problem here is about the welded portion. That is why we used almost, I should say, where I require 12 mm, I have used 20 mm or 25 mm. That is why extra factor safety has been allowed there. Okay. That's what we have done for the Tata housing as well in the other places also. But once it is embedded fully inside the ground, and even if it corrodes, heavens will not fall for us because with time the friction increases. In the driven bars, we never do any, what you call, galvanizing or any such treatment. We don't need to make it.
Especially I worried on the connection when you are steel channel.
Yeah, I know that. That's why we are not now making that type of welding. We are making the welding. We provide a channel behind, and to that channel on the face itself without bending the bar I am welding. That's the point.
Okay. Okay.
Mr. Okay, Swaroop has a question. Can you unmute and speak, Swaroop?
Sir, good evening, sir.
Good evening, Swaroop. How are you?
I'm fine, sir. Thank you, sir. Sir, any details of channel connected to the grouted nail is available, sir, for this Pramont project, sir?
Yeah, you can come and see that. It's not a problem. It's simple. In Pramont, what we have done is grouted nail into the channel. You mean to say in the gabion? Into the gabion?
Yes, sir. Inside the gabion. Yes, sir.
Yeah, simple. Rod, I make it and I make a hole in the channel which goes perpendicular to the bar, and there we weld it, or we can put a bolt net also.
Okay, okay.
As we did in our turnbuckle system in the
outer ring road project.
Outer ring road. Here also you can do that. It's not a big issue.
Okay. Okay.
Idea is anchored gabion was a point which was not there till then.
Okay.
We used the channel and placed the rock fill behind and front here, and then made the gabion at site condition in this in situ. Usual gabions, they make somewhere and lift it up and place it here and then go home. No, it's not right here. We didn't do that.
Okay. Fine, sir. Thank you, sir.
Thank you.
Bindu Madhava, can you ask your question, sir?
Namaskara, sir.
Yellappa, kalde hogbidtiyallappa neenu.
Sir, was it design life of the structure?
ಅದು ಗೊತ್ತಿಲ್ಲ, ದೇವ್ರು ಕಾಣಬೇಕು. ಯಾಕೆಂದ್ರೆ ನಮ್ ಲೈಫೇ ಗೊತ್ತಿಲ್ಲ ನಮ್ಗೆ. Design life generally, once it is sustained for few years, I can assure you after that it cannot go bad. Okay. Yes, but grouted anchors, grouted nails, they can sustain for even as much as your concrete can sustain. It's not a big issue. Question is what Swaroop asked is the question is right. That welded portion, how do you guarantee that will not corrode further?
Yeah, even the same question from me also. Just the same thing asked. And how you check the welding?
It's a possibility that yes, we have to take chance on that. But one thing I'll tell you, system will re-stabilizes by itself. Once if it has stood for 10 years without doing anything, I don't know whether you know that. In one of the projects I gave, my good friends had given a bearing capacity of the soil next to the existing building as something. But the owner wanted 2 more floors to be built on that. It's a stone masonry building. And I asked him when it was built. He said, sir, it was built 1935 is one. And then 1952 or something, another floor has been put. Now in 77 or 80, they have put 3rd floor. They wanted to put 2 more floors. Then I said, soil is so capable of work hardening, it has already withstood it. One thing we should know that, then I looked into the report. That report had given entire 5 floors together to be loaded. What we are doing in your SBC equations, the load is suddenly applied as if. That is a fundamental mistake. It's a work hardening material, incremental loading, and that too incremental loading is so sustained. Even construction period is 2 years, 1 year, 1.5 years. Then you will have got a lot of leverage with you. Let us see that way positively. Nothing wrong in that. I agree with you that yes, long life, what is there, what is not there, we should know that. Okay.
Yeah, Dr. Ramana has a question. Sir, please unmute and ask your question, sir.
Good evening, sir.
Yeah, good evening, Ramana. How are you?
Fine, sir. Fine, sir.
Tell me, sir.
Sir, one question, sir. For example, if there is a massive rock is there in between 2 RE walls, sir. So in such a situation, is it possible to adopt that technique, sir? What you have adopted, for example, rock bolting, maybe nailing, and RE walls connecting with certain high tension belts. Is it possible, sir?
100% possible. See, there are 2 issues.
Sir.
Normally, we grouted anchors, etc. We put it for developing the friction.
Okay, sir.
That tape, geotape, or what we call that, has been linked for transferring the tension.
Sir.
That either you can do with that, or because that is an advantage is it doesn't corrode.
Okay, okay.
And also we have used on the behind that in the that wall in the outer ring road, fully galvanized.
Okay.
So galvanized thing can sustain 100 years minimum, provided if you galvanize properly.
Sir.
Unfortunately, in India, what is happening, I don't know whether you know this point. Per square meter of the surface area, I need to use 2.5 kgs of zinc in the galvanizing. That is the correct method.
Okay, okay.
You calculate that. Then you will not get in micron. You will get the thickness in millimeters. Zinc thickness. Even today, the Hooghly Bridge, done in 1895 or 1890, everything is intact. Whereas after that, we have done several steel structures, already it's corroding. We should know what should be done, what should not be done, Professor Ramana.
Thank you, sir. Kaushal Joshi has a question. Can you unmute and ask Kaushal Joshi?
Yes, sir. Good evening, sir. Great presentation.
Yeah, sorry,
sir, you partly answered about the quality control, and my question was related to quality control and its impact on the design margin. Is there a way that a superior quality control and we can then readjust the design? Can we monitor?
Yes.
Any thoughts?
No.
Thank you.
The simplest, sir. This every day we are facing in Bangalore. Let me not comment anybody individually. We have got project management consultants who are supposed to look into all your quality control aspect. But that fellow doesn't know anything about the design detailing. And he simply thinks that putting a bar here, connecting a bar is good enough. How does he do? You should be able to debate it with the designer. Yes, this can be done or cannot be done. They should be arriving it at that. There are very few people who themselves are good structural engineers. Or can you believe that I have seen nowadays one architect becoming a PMC? How can they control quality? These are the small issues, but we should professionally come out with clarity, and we should tell people that you should not do it. You understood, Kaushal?
Yeah.
Yeah.
Absolutely, sir.
Thank you, sir. Srinivasan has a question. Please unmute and speak. Please.
Sir, good evening, sir. Namaskara.
Namaskara.
Sir, we want to know how exactly the deep well dewatering system work in reducing the groundwater table below the excavation levels during execution. What are the repercussions for the adjacent buildings, foundations, which are very close proximity to the property line? Number one. And number two, and what should be adopted, what one should adopt for the grouting of the microplace annular space and the grouted anchors when there is groundwater table, dewatering system is running 24/7, not very effectively, sir. Thank you.
Srinivasan, one thing is always required. There is a system by which you can design the dewatering system.
Yes,
what
sir.
should be the spacing of the bore wells that I have to install on the outside of my retaining wall? From the ground level, I have to install them. How deep I have to go here? I'll give one example. In Mundra, in Gujarat, Adani's project, there is just a reclaimed land of 2,500 square kilometers of land they have reclaimed. But they are building a lot of ports and other things there. And very 10 meters away from the sea, they have to go for a, 16 meters of excavation. And the water level is exactly at the ground level or 1 meter, 2 meters below. Then they're not sure, they went for diaphragm wall, they went for this, that, etc. And they started excavating, the whole water started coming up from beneath. Okay. One thing is, if the head of water above is 15 meters, can you believe that I have to take at least 22.5 meters below the excavation line, the diaphragm wall? That the people do not understand that. Because 3 times the head of water should be, it should form that path. Minimum. Then only you can prevent it. Otherwise, it will not be possible. So therefore, we should focus on some of these dewatering system. One thing I'll tell you, you drill a hole of 300 mm diameter and insert the casing pipe first. The casing pipe shall have collar joints at every 1 meter.
Yes, sir.
It should be openable. Then you insert into that in the center porous pipe, which has got 6 to 8% of the surface area holes.
Right, sir.
That will be wrapped with the geotextile filter cloth of appropriate. If the soil is clayey, I may have to use thicker one. If it is sandy, I may have to use thinner one. Right, that is GSM. Grams per square meter is a specification for all the geotextiles. If I want to use for the clay, I may have to go for the 250 GSM or 200 GSM. Then if I want to use for sand and gravel, I may require only about 150 GSM. Right. That shall be wrapped. Then I insert the pipe into the casing pipe that has been already in position, but the annular space has to be filled with good aggregate or the gravelly material. But if you fill up, you can't withdraw. So fill up 1 meter, lift up. That's why collar joint has been provided. Remove on the top. Again lift up, again remove. Sir, this is the method that should be followed, but unfortunately people do not understand this. Simply they think that 6 meter pipe is there, so I have collar jointed for 6 meters. If you fill up 6 meters and lift it up and the entire thing collapses, that I have seen.
Okay.
Kindly careful about it. And I'm too sure that you can't find this any textbook. You have to practice, you have to learn from site for yourself.
Agreed, sir. Thank you so much for your
No.
So the last 2 more questions, sir, we'll take and we'll wrap up. I think NTPC has a question. Please unmute and speak, sir. NTPC.
Very good afternoon. Good evening, sir. It's a nice presentation, all the practical and live problems. Since you mentioned about corrosion, I have also given the chat saying that embedded things are very minimal for corrosion once if they are GI.
Yeah.
But I have only one caution in case of dewatering. You have mentioned about the geotextile. We have also done a lot of dewatering adjoining the water bodies. But if the geotextile or the sea, what you are trying to dewater, if it gets choked, then the purpose, what we presume that it is getting dewatered, but the function gets defunct.
No. Let me see. Actually, dewatering is not open well. It is through the filtered material, water only comes inside.
Correct.
Into the pipe. And important is I am fixed around that, I am wrapping with the geotextile filter cloth, which itself cannot get choked. That I can assure you. Why I will tell you it cannot get choked. For choking, what is required is the surface charge of the two materials should be there, negative, positive, then only it can stick. Can you believe that our geotextile filter cloth has no charge at all? It's neutral. And soil has got negative charge. Maybe say something else has got positive charge, but it doesn't get stuck there. It will go out. It passes through. That nothing goes through. That's why we provide a filter layer also behind that. That means granular material and then the natural soil. This we are using. I think we have done even 25 meters, 30 meters. Absolutely, there's no problem at all.
Actually, in water-bearing strata, sir, when it is having silt, it is a silt that creates silt, as you rightly pointed out, Clay also. The silt is a thing which is a troubleshooter.
No. Then what you said is, I will tell you, sir. You need to space your, if I go for the silty clay material, my spacing of the bore wells will be within 5 meters, 4 meters. If it's sand, I don't know whether in one project in Chennai, across the building, I installed the borewell on that side and this side. From there, I started evacuating water. The other side became dry. That means below, water can flow beneath that. That's not a big issue. But careful about it, because of that, undermining should not take place. And it did not, if you allow the soil to retain in the position, nothing goes wrong, only water should be taken out. That's where the filter cloth helps a lot. And also a granular layer behind that.
Nice, sir. We had a bad experience. That's the reason we...
Where, sir?
No. Professional ethics doesn't permit me to say the name.
No. Please, I'm talking. I don't ask anybody. Name, I'm not asking you. Please, if it is
it's a water-bearing strata adjoining a river. But it got choked, and then we have gone with the sheet piling method. And we tried to lower it through open pipe, but unfortunately the water came into the excavation pit, which is about 26 meters below the ground level and about 15 meters below the riverbed level.
Sir, this point what I said you in Mundra project, it was 16 meters was the excavation. They had installed the diaphragm wall already, and adjoining that is the sea within 10 meters from there. But they didn't know. But we adopted for a 20 meter by 20 meter pit to be going dewatering, 675 HP of dewatering system with bore wells so closely spaced, and then again pumping continuously 24/7, and we were successfully installing the raft below that. Okay, that's the. Yeah. It can be done.
Yeah. Thank you, sir.
It has been actually. So Toyo Engineering from Tokyo, they were the consultants, and the implementing authorities were from our own groups of many engineers. And it's okay. It happens sometimes, but somewhere it clicks.
We'll take the last question, sir.
Yeah,
you can conclude here. Dr. Balkumar, please ask your question. So this will be the last question. If you have anybody have any question, kindly send us the email, sir. We will discuss with professor and respond. I have put the Google link form. Kindly fill up the Google link forms. We will share the copy of the presentation.
Sir, I am Ramesh. I have one question, last question. After.
Okay, after Balkumar. Balkumar first. Balkumar.
Sir, good evening.
How are you?
Fine, thank you, sir. How are you, sir?
I am fine. I did not hear about you anywhere. What is happening? I was wondering.
Please ask your question, Balkumar.
Yeah. See, the question is that was there any monitoring done for any lateral deflection, and what was the initial shear strength of the soil there? Because Bangalore, the soil has got natural shear strength itself is quite high.
Yes.
So, I want to know whether was there any monitoring done after such a deep excavation, and was there any lateral displacement or anything like that? Was it done anything like that?
No, this you are talking about my diaphragm wall. What I said, the soil diaphragm wall.
Yeah.
Okay. First point is the diaphragm wall has been installed before starting the excavation.
Okay.
I prefer everything to be structurally strengthened enough so that it is either anchored or sulfite itself can help you.
Okay.
Therefore, I'm not worried about the sheer strength of the soil below that. In fact, I will tell you,
Okay.
sheer
Okay.
strength is a very bad misnomer that has
Okay.
been put into our system.
Okay.
Actually, it's a process by which it strengthens by itself. Work hardening material, soil. As I start excavating somewhere here, I don't excavate in a single blow for 16 meters. It takes 1 year. In that period, restabilizes, redistributes, works better. That is the beauty of the, just like curing by Ayurveda rather than allopathy.
Yeah.
Okay.
Chen Ramesh, can you ask a question?
Thanks.
Helappa, Ramesh.
It was really an excellent presentation. Thank you very much, sir.
Thank you, Balakumar.
Yeah. Professor Ramesh.
ಸರ್ ನಮಸ್ಕಾರ ಸರ್, ನಾನು ಎಚ್ ಎನ್ ರಮೇಶ್.
ಗೊತ್ತಾಯ್ತು, ಹೇಳಪ್ಪ.
ಚೆನ್ನಾಗಿದ್ದೀರಾ ಸರ್?
ನನ್ನ ಬೋರ್ಡ್ ಮೇಲೆ ನಿನ್ನ ಹೆಸರು ಬರ್ತಾ ಇದೆ, ಅದಕ್ಕೆ ಹೇಳಿದೆ.
ಸರ್, I have one general question about the deep excavation. ಈಗ ನಮ್ಮ ಗೋಲ್ಡನ್ ಗ್ರ್ಯಾಂಡ್ ಅಪಾರ್ಟ್ಮೆಂಟ್ ಅಂತ ಇದೆ ಒಂದು ಇದರಲ್ಲಿ.
ಗೊತ್ತಪ್ಪ, ಹೇಳಪ್ಪ.
ಯಶವಂತಪುರದಲ್ಲಿ. ನೀವು ಇನ್ವಾಲ್ವ್ಡ್ ಇನ್ ದಿ ಫೌಂಡೇಶನ್ ಡಿಸೈನ್ ಎಕ್ಸೆಟ್ರಾ. ಐ ಆಮ್ ಸ್ಟೇಯಿಂಗ್ ಇನ್ ದಟ್. We have 3 blocks. ನಮ್ಮ ಅಪಾರ್ಟ್ಮೆಂಟ್ ಫೌಂಡೇಶನ್ ಬಂದ್ಬಿಟ್ಟು 1.8 meters raft foundation below the basement. So adjacent to that, around 10 to 15 meters away from our site, adjacent to the Yeshwanthpur road, they are going for the 45 feet excavation, and some other agency want to go for 45 feet excavation, whereas the foundation depth here is only 1.8 meters, that is 6 feet. So we thought there will be some problem, for the due to deep. They are not taking any precautionary measures. Simply they are going for the excavation.
ಇಲ್ಲಪ್ಪ, ಸಿಂಪ್ಲಿ ಓಪನ್ ಎಕ್ಸ್ಕವೇಷನ್ ಮಾಡಬಾರ್ದು. ಒಂದು ನಿಮಿಷ ಕೇಳಿಕೊಳ್ಳಿ. ಇಂಜಿನಿಯರಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ಮರ್ತು ಬಿಡ್ತೀವಿ ನಾವು. 1930s ಅಲ್ಲಿ 40s ಅಲ್ಲಿ ಟೆರ್ಸಗಿ ಶುರು ಮಾಡಿದಾಗ ಒಂದು ಫೌಂಡೇಶನ್ಗೆ ಇಷ್ಟೇ ಎಕ್ಸ್ಕವೇಷನ್ ಮಾಡೋದು, ಅದಕ್ಕೋಸ್ಕರ ಇದಿದೆ ಹೊರತು ಈ ತರ 3 ಬೇಸ್ಮೆಂಟ್ 5 ಬೇಸ್ಮೆಂಟ್ 6 ಬೇಸ್ಮೆಂಟ್ ಯಾರಿಗೂ ಗೊತ್ತಿರ್ಲಿಲ್ಲ. ಎರಡನೇದು, ಬೆಂಗಳೂರಿನಲ್ಲಿ ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ ದಿ ಮಾಫಿಯಾ ಆಫ್ ದಿ ಬಿಲ್ಡರ್ಸ್ ಪುಟ್ ಟುಗೆದರ್, ದೇ ಹ್ಯಾವ್ ಮೇಡ್ ಯು ಕ್ಯಾನ್ ಎಕ್ಸ್ಕವೇಟ್ ವಿತಿನ್ 2 meters ಫ್ರಮ್ ದಿ ಬೌಂಡ್ರಿ ಈವನ್ ಫಾರ್ 6 basements 4 basements. ಹೆಂಗ ಡಿಸೈನ್ ಮಾಡ್ಕೊಳ್ಳಿ ನೀವು. ಬರ್ತಾರ ಜನ, ನಾನು ಡಯಾಫ್ರಮ್ ವಾಲ್ ಹಾಕ್ತೀನಿ, ಕಪಾಲಿ ಥಿಯೇಟರ್ ಹತ್ರ ಬಿದ್ದೋಗ್ಲಿಲ್ವೇನಪ್ಪ? ಅಲ್ಲೆಲ್ಲ ಕೇಳಿಸ್ಕೊಂಡು ನಾನೇ ಹೇಳ್ತಿದ್ದೀನಲ್ಲ. ಈಗ ಅದನ್ನ ಇನ್ವೆಸ್ಟಿಗೇಟ್ ಮಾಡಿ ನನಗೆ BBMP-ನವ್ರು ಕೇಳಿದ್ರು. ಐ ಹ್ಯಾವ್ ಗಾನ್ ಥ್ರೂ ದಟ್ ಅಂಡ್ ಐ ಫೌಂಡ್ ದಟ್ ದಿ PT anchors, post-tensioned anchors inside the soil cannot work. Why? Soil is work hardening material. It starts compressing with time. Once it starts compressing, what is happening? Your extension that has been made for the cable vanishes. ಇದು 1998 ಅಲ್ಲಿ 98-99 ಅಲ್ಲಿ ಬಾಂಬೆ ಲೋಯರ್ ಪರೇಲಲ್ಲಿ ದೊಡ್ಡ ಪ್ರಾಜೆಕ್ಟ್ ನಮ್ಮ ಸ್ಟರ್ಲಿಂಗ್ ಬಾಂಬೆನವರು ಡಿಸೈನ್ ಮಾಡಿ ಪಾಪ ಕಷ್ಟಪಟ್ಟಿದ್ರು. ಎಲ್ಲ ಆಂಕರ್ ಎಲ್ಲ ಮಾಡಿದ್ದಾರೆ. ಎಕ್ಸ್ಕವೇಷನ್ ಶುರು ಮಾಡ್ತಾರೆ, ದಬಕ್ ಅಂತ ಬಿದ್ದೋಯ್ತು. ಎಂಟೈರ್ 4.5 acres ಫೋಟೋಸ್ ಬೇಕಾದ್ರೆ ಕಳಿಸ್ಕೊಡ್ತೀನಿ ಯಾವ ತರ. ಇದು ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ವಿ ಹ್ಯಾವ್ ಕನ್ಫ್ಯೂಸ್ಡ್ ಅವರ್ ಸೆಲ್ಸ್. ಪೋಸ್ಟ್ ಟೆನ್ಷನಿಂಗ್, ಪ್ರೀ ಸ್ಟ್ರೆಸ್ಸಿಂಗ್ ಎಲ್ಲಿಗಾಗುತ್ತೆ? ನಾಟ್ ಹಿಯರ್. ಪ್ಯಾಸಿವ್ ಆಂಕರ್ಸ್ ಓನ್ಲಿ ವರ್ಕ್ಸ್ ಫಾರ್ ಅಸ್, ನಾಟ್ ಪೋಸ್ಟ್ ಟೆನ್ಷನ್ಡ್. ಸೊ ಇಲ್ಲಿ ಬೆಂಗಳೂರಿನಲ್ಲಿ ಅದನ್ನ ಮಾಡ್ಬಿಟ್ಟು ಗೋಳಿ ಕೊತ್ತಿಯಾರ ನಮ್ಗೆ. ನಾನು ಅಹಮದಾಬಾದ್ ಬಂದಿದ್ದೀನಿ ಸರ್, ನನ್ಗೆಲ್ಲ ಮೆಷಿನ್ ಎಲ್ಲ ತಂದ್ಬಿಟ್ಟಿದ್ದೀನಿ, ಮಾಡ್ತೀನಿ ಸರ್. ಅಯ್ಯೋ ಮಾಡಿದ್ ಕೇಳಿ ನಾವೇನಾಗಬೇಕು, ಮಾತಾಡಲ್ಲ. ಸೊ ಅದರಿಂದ ಇಲ್ಲಿದು ಗೋಲ್ಡನ್ ಗ್ರ್ಯಾಂಡ್ ಪಕ್ಕದ್ದು, ಈಸ್ ಇಟ್ ಬಿಲಾಂಗಿಂಗ್ ಟು ದ DNR ಗ್ರೂಪ್?
ಅಲ್ಲ, ಅಡ್ಜಸೆಂಟ್ ಅಲ್ಲ, ಪ್ಯಾರಲಲ್ ಟು ದಿ ಯಶವಂತಪುರ ರೋಡ್, ಬಿಟ್ವೀನ್ ದಟ್ ಮೇಪಲ್ ಬ್ಲಾಕ್ ಅಲ್ಲ ಫರ್ನ್ ಬ್ಲಾಕ್ ಅಂಡ್ ಯಶವಂತಪುರ ರೋಡ್ ಒಂದು ಪ್ಯಾರಲಲ್ ಗೆ ಒಂದು ಸೈಟ್ ಇದೆ. 100 meters by 50 meters ದೊಡ್ಡದು. ಐ ಆಮ್ ನಾಟ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ GP ಫ್ಲೋರ್, ದಟ್ ಇಸ್ ಇನ್ನೊಂದಿದೆ ಆ ಕಡೆ ಬರ್ತಾ ಇದೆ, ದಟ್ ಇಸ್ ನಾಟ್ ದಟ್ ಒನ್. 50 floors ಅಲ್ಲ, 50 floors ಅಲ್ಲ, ಇನ್ನು ಈ ಕಡೆ. ಸೊ ನಮ್ಮ ಕ್ವಶನ್ ಈಸ್, we stopped the excavation and they have gone up to 15 feet. We complained BBMP and Prasad helped us, chief engineer. We stopped it. Hope we are right.
Thank you.
ತಪ್ಪಿಲ್ಲ. ಒಂದು ವಿಷಯ, there are 2 issues. ಅವನು ನಿಮ್ಮ ಬಿಲ್ಡಿಂಗ್ ಅಡಿಗೆ ತಗೊಂಬಂದು ಆಂಕರ್ಸ್ ಎಲ್ಲ ಹಾಕ್ತೀನಿ, ಅದು ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ತಪ್ಪು. ಎರಡನೇದು, ಅವನ್ ಪ್ರೊಟೆಕ್ಷನ್ ಸಿಸ್ಟಮ್ ವಿತ್ ಇನ್ ಇಸ್ ಲ್ಯಾಂಡ್. ಈಗ ಉದಾಹರಣೆಗೆ ನಾನು ಸಾಯಿಲ್ ಡಯಾಫ್ರಮ್ ವಾಲ್ ಕೊಟ್ಟನಲ್ಲ ಈಗ ನಿಮ್ಗೆ.
He has not done any excavation.
ಅಲ್ಲೆಲ್ಲ ಹೇಳಿದೆ, ಸಾಯಿಲ್ ಡಯಾಫ್ರಮ್ ವಾಲ್ಗೆ ನನಗೆ ಬೇಕಾಗಿರೋದು, ಇಫ್ ದಿ ಹೈಟ್ ಇಸ್ ಡೆಪ್ತ್ ಆಫ್ ಎಕ್ಸ್ಕವೇಷನ್ ಇಸ್ H, ಐ ನೀಡ್ ಟು ಹ್ಯಾವ್ ಎ ಮಾರ್ಜಿನ್ ಆಫ್ ಮಿನಿಮಮ್ 0.35 H on the top, or at least 0.3 H. ಈಗ 10 ಮೀಟರ್ 3 ಮೀಟರ್ ಇರಬೇಕು, 15 ಮೀಟರ್ 4 ಮೀಟರ್ ಇರ್ಬೇಕು ಜಾಗ. ಅವನು 2 ಮೀಟರ್ ಇಟ್ಕೊಂಡು 16 ಮೀಟರ್ ಎಕ್ಸ್ಕವೇಟ್ ಮಾಡಕ್ ಹೋಗ್ತಾನೆ. ಅದು ಪ್ರಾಬ್ಲಮ್.
Definitely that will affect our building.
It may not now because we don't know. You have stopped it.
We have stopped it. Alala, without any precautionary measures, they are going ahead. That can be stopped.
It's a good thing you did, but let me see what they have done it wrong or right. Okay.
Yes, sir. Yes. Thank you, sir.
Thank you, Professor. I think we will conclude this session, sir. Now, thank you very much, and I request our secretary, Professor Anbalgan, to propose the vote of thanks. Anbalgan, over to you, sir.
Yeah, thank you, Dr. Farsadi. So, all of us will agree that we had a very excellent evening with Professor Srinivas Murthy lecture. So, no need to say that he is one of the well-known expert in India dealing with the different anchoring problems. So, he has shared 4 nice case studies, okay, which is remarkable. So, we all remember Terzaghi because he has written an equation for all his findings in the tower tilting. So the same way we should also, like India side also, people should have some kind of mechanism to make all this explained in the equation so that the next generation carries a similar kind of experience. So I request Professor BRS on this to make some kind of effort so that in future generation also learn this apart from the present we are listening that presentation. So I thank Dr. Raghuveer Rao to give an excellent overview of Professor BRS, and also all participants who are excellently interacted with equal to the lecturing time. So that's wonderful, and also shared their comments and views about the presentation. So we look forward all of them again in the next lecture in IGC Bangalore chapter. So we thank especially Professor B.R. Srinivas Murthy for sharing his experience on the nice evening time. So thank you very much, sir. So thank you for all the participation. So we look forward in the next lecture. Thank you very much.
I should thank you all for patiently hearing me because we are getting old. Coherence will not be there in talking. Sometimes we get confused between this sentence and that sentence. That's why it goes like that. And you know that we don't prepare and keep ready any handwritten text. We spontaneously speak. It happens. It happens. Okay. Thank you all for patiently hearing.
Yeah. Thank you. Thank you, Professor. Thank you, sir.
An excellent presentation. Thank you.
Oh, thank you very much, Bindu. Thank you, Raghuveer.
Thank you, sir.